We're going to do number 5 based on this set of graphs. G of negative 3, that's asking when x is negative 3, I'm going to go to negative 3 on the x-axis, what is the value or the output of function g? So I'm going to go, at x equals negative 3, I'm going to go up to function g. The y value is 2. If f of x equals 2, this is the y value on function f. So on the y-axis, I'm going to go to 2. What was x? So on the y-axis, I'm going to go over to function f, and then look to see what x is equal to. X is equal to negative 1. G of f of negative 5, we have 2 steps. F of negative 5 comes first. 1, 2, 3, 4, negative 5. I'm going to go up to function f when x equals negative 5, and look at what the output is. My y value is 1, 2, 3, 4, 5, 6. But then I'm doing g of 6, so that becomes my input, 1, 2, 3, 4, 5, 6, and go up to function g. It's a little bit off the graph here. That is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one says if f of g of x equals to what was x. So f of something should give us 2. Let's do that first. My output is 2. I'm on function f, so the input had to be negative 1. So now I know that g of x had to be equal to negative 1. But I'm trying to figure out what x was equal to. So when g of x equals negative 1, that's the y value is negative 1. I'm going to go over to function g and look up the x value. X is equal to negative 6. At what value of x is f of x minus g of x equals 0? Well, if two things are subtracted and give you 0, that means they're equal. So in other words, where are these two functions equal? That is where they intersect. So that is when x equals negative 2.